Good morning. Good morning. We're going to be waiting for another minute just to see, who else is joining. But what we can say, we're opening the kind of series of the electrification webinars in cooperation with Electrification Alliance, and as a series, on our eLITHE project. But let's wait for another few seconds. Let's see. We have. People are coming in, which is good, and obviously kind of shows, importance of the electrification as a subject. Here in Brussels, we are looking towards the electrification strategy coming up early next year. So it's very, very topical. I think we can start, not to wait for too long. If we can have agenda, please. As an introduction here at the EIP, Energy Efficiency Industrial Process, by the way, I'm Dusan Jakovljević, I'm a policy director here. We have been working on heat, industrial heat, as one of the main elements for decarbonizing European industries. And this has been really like one of our cornerstones of work. And in the last few years, there has been sort of more initiative to see to electrify heat, and especially high-grade heat, which is kind of quite problematic, and comes into the technologies which are often perceived expensive, and there is a broad range of these electrification technologies for high-grade heat. On the lower temperatures, we have seen, kind of really major successes of the heat pump sector. In the way the temperatures can be managed, where like on these sort of furnaces, on energy intensive sectors, we still have a small gap to fill. It is a niche really into kind of discussions in Europe, on this sort of electrification of high-grade heat for a variety of reasons, because also, some sectors, like a little bit reluctant because of the cost, which might occur on their members, but then also, really this sort of, complexity of the technologies. So basically the idea of the webinar today is to kind of position, really sort of to build up the picture of this niche electrification markets. So we will be starting with a keynote from Adrian Hill, who is the director of Electrification Alliance. And Electrification Alliance, they have been kind of the leading advocacy body here in Brussels to promote crossover electrification, not just the industry, but they also work a lot in buildings and transport. So and then after that, we will be having a presentation from Matthias from the Fraunhofer Institute, where, because they have the Fraunhofer Institute for the German ministry, they developed the study, which is still kind of the most authoritative study in Europe on potentials of electrification of these sectors. So it's basically kind of reference point. So with Adrian opening like on a policy side, we're going to have actual kind of market potentials, presented, with Matthias. And after that, we will have a presentation to two projects. One where EIP is partnering, eLITHE, and Roberto from Circe, who are the project managers. They will tell us more about the specific technologies, specific sectors they work in eLITHE. And after that, we'll have a presentation from Sven, from the CITADEL project. And they do like a little bit different, and it's very sort of compatible. So I'm happy really to invite Adrian now to start with his keynote. Thank you.
Great. Hey, thank you very much for having me, Dusan. It's a real pleasure to be here. As you say, industrial electrification is a really key topic. I mean, electrification in general is a really key topic right now, but there's no question that the industry is a really key focus. Just taking a moment to introduce the Electrification Alliance, for those of you who don't know it, it's 10 organizations based here in Brussels, representing the whole supply chain from the copper that goes into everything that will be electrified to wind and solar that's going to provide that electricity. Electric, whose members are going to sell it. Smart N, who's going to make sure that we do it wisely. E-Mobility Europe, the Heat Pump Association. It's a whole group of organizations, and together we tell this story of electrification and what it can do when we change our whole energy ecosystem. So to give you a timeline of where we are right now, to my mind, this autumn represents the beginning of Act 2 of the energy transition. Right, the last sort of 15 years or so since the initial Renewable Energy Directive, that was all about disrupting the power sector. Right, we've done a phenomenal job of bringing in wind and solar into the power sector. I think about 377 gigawatts of renewables in over 10 years, which is just a phenomenal amount. Our grid is now 72% clean, and that we can look back at that Act 1 as a success, but what it does is it sets the stage for Act 2, which is getting that clean electricity into our buildings, into our industry, and into our transport. So whilst buildings and transport obviously have very clear desires, the fact of the matter is you're talking about a lot of units. When it comes to industry, there's a much greater focus right now because the process is that much cleaner. It's about building the business case. And if you can build the business case, you can electrify. And if you can't, it's going to be very, very difficult. But the decision process is so much faster because the units are that much bigger and fewer in number. On the political scene, one of the reasons, and in fact, the biggest reason why we've seen a change in tone this autumn is the geopolitics of it all, right? If we look at the top 5 countries that send us fossil fuels, Qatar, who's handed out suitcases full of cash in the European Parliament and threatened to withhold gas this summer because of EU human rights legislation. The US, who speaks of energy dominance, and there's no question about who they're planning on dominating. And of course, Russia, who have invaded Ukraine to our east and continue to kill people every day. These are not our friends. Whereas the climate movement was very much what we should do, what we want to do, the geopolitical position we're in now is that this is what we have to do. And if we want to move really, really fast, industry is going to be the key lever for reducing our exposure to that imported natural gas. In the last few weeks, we've seen both European Commission President Ursula von der Leyen, Dan Jorgensen, the Energy Commissioner, Commissioner Hoekstra, and Commissioner Ribera all make very, very, very strong statements, really clearly laying out that electrification is the path for how we get off our dependence on imported fossil fuel. And what we're seeing from the policy side to do that goes along with that is a couple of weeks ago we had the terms and conditions of the industrial electrification auction were announced. This is a really, really key initiative because it gives companies the money they need to invest in the equipment they need to electrify. Now, honestly, right now, as Dusan was saying, we're going to see a lot of that going into heat pumps and low temperature process heat, because that's the commercially mature equipment. What we're going to hear about today is the equipment that I expect will be bidding in that auction in a few years' time, because that's clearly the future and that's clearly what we need to do. So one thing that we're asking the Commission to do is to make this auction permanent, because we're going to need it more and more as the years go on. And it's going to be about disrupting this high temperature process heating. That's really, really key. So aside from the auction that we've seen, we've also got the Electrification Action Plan, which Dusan said is coming in Q1, probably March of 2026. There's a big consultation tomorrow in Brussels, in fact, where we'll be presenting the Electrification Alliance's asks for what should be in there. But the really crucial thing to remember there is that we don't need a whole lot of sweeping legislation in Europe to electrify. Most of what we need is already there. Where we're falling down is in the implementation in member states, right? We talk a lot about electrification being stagnant at 23% in Europe. The fact is that average hides a whole slew of variables where we've got areas within Europe that have already electrified to a really, really high degree. It shows that it can be done. There's no question about that. The fact is we need the member states to put in the legislation and implement the EU policy to make those business cases. So that's really, really exciting. Other than the Electrification Action Plan, which is coming up, that's part of a broader package as well. The grids package is due out on December 10th. That's going to be a really key piece of legislation because a lot of the, especially high temperature process heat, you need a big grid connection. And in some countries, that can be exceedingly difficult right now with waits of 7 to 10 years kind of thing. So the good news is everyone's agreed we need to reform how we deal with the grids, how we determine what grids get built and who gets access to that. There's no debate about that. So I'm quite optimistic that the grids package that comes out December 10th is going to be a real help for allowing these high temperature process heats to connect to the grid so that we can effectively electrify these industries. The other thing we're going to see in the next few months is the heating and cooling strategy. That will come out at the same time as the Electrification Action Plan. And that's going to really deal with the sector coupling, what we call the system integration. So where you've got waste heat, say from a high temperature process, electrification process, we want to make sure that we can take that heat and use it for something else as well, rather than just putting it into the atmosphere. It's a valuable resource, but we need to make sure we have the policy in place so that companies can profitably take advantage of that. And then as well, the main political driver is we're going to have the security of supply package in March of 2026, and that's really about making sure that Europe can keep the lights on. And when it comes to keeping the lights on, there's no clearer message we can have than the fact that putting European energy, which is renewable and clean, putting that European energy into our industry, into our homes, and into our transport is the single greatest way we can keep those lights on, rather than being dependent on the geopolitical forces and countries that are not our friends at all. Dushan, that's how I see it. A big picture, both the politics and the technology. There's going to be other acts after this, right? So right now we're focusing on the low temperature heat. In a few years, it's going to be the high temperature heat. And then in years to come, there will be other sectors that are going to electrify, and we'll get there bit by bit. But until then, I'm really looking forward to today's webinar because these technologies are so important to have in place in a few years' time.
Thank you, Adrian. I mean, this is really crucial, and the way you position it, it seems to us, that there is, really like the policy is looking at us. And from what we know also from CINEA and from the programs, they are picking up the elements and they are looking, really to build up, as you said, the business case for the high grade heat. Matthias, you can tell us what are the potentials for the high grade heat in Europe, and if you can share your screen and tell us your views, please. Thank you.
Yes. Hello, everyone. Happy to be here. Thank you, Adrian, for the introduction, and to Jan. Indeed. Okay, let me start this way. We don't have a lot of time, and I want to get as much information to you as possible. So I hope the slides are shared now. Yes, works. Perfect. Then quick introduction. My name is Matthias Rehfeld. I work as a scientist at the Fraunhofer ISI here in Karlsruhe, Germany, and my research group and me, we work on the decarbonization of the European industry, and in recent years focus on electrification. And today I want to present you some insights we derived from 2 publications of the last years. You see it here on the right side. One was done nationally for the Federal Environment Agency on decarbonizing CO2 process heat, and the other one is the one that has already been mentioned. Now, without a lot of additional talk, let's start. I want to show you today first a quick introduction, what we know about process heat in the European Union, then some technical challenges we identify for high temperature heat, the technical electrification potential we can derive from that, then a quick excursus at why it is so urgent to do something about industrial heat, And then let's have a look at the cost and other barriers we see for implementing these potentials. First, our main assumption is that the demand for basic materials like cement, steel, paper, plastics, and so on will remain. Also, by the end of this century, we will be using these materials. However, the way we produce them has to change. And I want to make an argument for that on this slide. What you can see here in this pie chart is the amount or the share of energy carriers that we use to produce process heat today in the European Union. About 1/3 of process heat generated is generated with natural gas. We refer to it as the reference energy carrier because it is present in all industrial subsectors. When you want to replace process heat in terms of fossil fuels, if you want to electrify it, you have to beat natural gas somehow in a technical and an economical way. Then another third is coal and coal-derived energy carriers, but that's mostly located in the iron and steel industry. Then we have some use of biomass, highly niches where there are internal residues from the production. So it's not something you can roll out across the entire process heat requirement. And lastly, at the moment, roughly 4% of process heat production is electrified. This, again, is highly localized in the iron and steel industry for electric arc furnaces in the secondary steel production route, but not so much in other industries. So main takeaway here should be that when you sum all of that up, 75% of the process heat generation in the European industry is still fossil. And that's what we think has to change. So when we look at this process heat, it's not just any process heat. The temperature level is of high importance to identify which technologies could be used to decarbonize this energy use and what the challenges are. We distinguish two large categories. First, low temperature heat, low to medium temperature heat, which is hot water and steam usually, and we make the cut at 500 degrees Celsius. In other publications, there might be at 400 degrees, but that doesn't really change much. Now, today I want to talk about the high temperature heat. And as you can see on the right side, that's an example for Germany, but it's similar for the European Union. It takes a lot of energy. So the darker areas are, darker orange areas are high temperatures in iron, steel, in basic chemicals, but also in glass, ceramics, non-ferrous metals, and so on. For those high temperature heat, the technical solutions are highly specific. You cannot use the same furnace and kiln, so the same process heat installation for the production of cement or for steel. It's very different, and that creates a challenge. Now, so far for the introduction. In the next few slides, I want to talk about what the technical challenges are actually, which potentials could still be realized and might be realizable in the next years. And third, what are non-technical barriers? Let's jump into it. First of all, let's start with there are challenges for high temperature applications in process heat generation. What we can see here on the left side are several technologies that might be used for process heat pumps, electric boilers, obviously for the low temperature areas. And then we have resistance heating, which is currently the reference technology for electrification in high temperature area. In addition, induction heating and electric arc furnaces. However, the latter two have restrictions in terms of materials that can be processed and geometries that can be processed. I'm happy to say that in the next discussions we have, there will be some insights on how to extend these limitations or resolve them. Resistance heating is primarily limited by the energy density of the energy that can be applied. So for high temperatures and high capacities, there are currently limitations what can be electrified. Thus, there is a gap in the high temperature area, and that's discussed here or presented here, roughly at about 1000 degrees Celsius, and in high capacities, there is a lack of technologies to cater to these demands. In our publication, we investigated this and we see two options. First, we think that the applicability of induction heating and electric arc furnaces in some cases can be extended to more materials to resolve issues with geometries. And the second would be to introduce new technologies that are currently not on the market, like plasma torches and shockwave heating. And these together could close the gap in the high temperature era we see and would allow to electrify all of or most of process heat generation and demand. How much of it indeed? Let's have a look at this diagram, also from the same publication. And due to time restrictions, just stick to the right side. That's the final energy demand in European industry as of now. And we can see that about 1/3 is already electrified. However, that's not process heat. That's usually electricity used for motors, for drives, cooling, lighting, electrolysis, and so on. However, already today, additional 40% of the energy demand could be electrified with technologies that is already available. That's in many cases, that's low to medium temperature heat, steam, hot water. However, also high temperature heat is included in there. You can already address several applications of high temperature heat with existing technologies. We estimate that you need new technologies or an extension of technology capabilities to electrify additional 20%. And we think that these technologies can be available by 2030 or 2035. This leaves us with just 10% of current industrial energy demand that cannot be electrified, mostly because it requires molecules for reduction, for example, in the iron and steel industry. There are some areas of energy use in the chemical industry that is not included here. Feedstock for the chemical industry needs molecules because it appears in the product, and that's not covered here, but it's a large share of the total energy use, up to 1000 terawatt hours. So there is still enough room to use hydrogen and other energy carriers. So now some quick thoughts about the urgency. What we can see here on the left side is an example of some processes and applications for process heat we investigated in the study you see on the top right. And what we found is that the technical lifetime of the installations used in these applications is so long that in most cases you have less than one investment cycle remaining before we want to reach climate neutrality. So any fossil installation installed today, invested in today, will be there in 2050 and will still emit greenhouse gases. That's a problem because in many cases there is today not a business case, and that's something I want to show on the next slides. But you already know that when you invest in a fossil installation now, you will lose parts of the technical lifetime. The options would be, if that happens, to just stop producing, to not emit greenhouse gases anymore, or to fail on climate ambitions, just keep emitting. And both of those are very unattractive options, we think. So what we could do today is to combine electrification, modernization of existing installations in process heat generation in the European industry, and at the same time increase the efficiency of these installations to also increase competitiveness. That's the main idea of this diagram here. So regarding the time, let's have a quick look at the main barrier we identify, and that's the economic situation today of electrification. I can't go too much into detail, but what we can see on the right side is the heat generation costs of process heat. And what we want to reach is to get to this red line. That means that you would have no extra costs when you produce process heat via electrification, compared to the use of natural gas, for example, or just any fossil installation. We can see that in steam generation, there are some, these are the whiskers are the outliers basically, some applications where that's possible. For metals and minerals, it's harder. And we investigated some cases, some different cases in which electricity price is lower, in which the CO2 price is higher. And these cases can reach cost parity with fossil fuel installations. So that's what Adrian mentioned. It's about building the business case. What can we do to reach this business case to enable the implementation of the technical potential I showed earlier? Last slide, and just to mention that economic challenges are not the only ones. The technical challenges seem manageable. The economic challenges require policy action, but there are also other challenges like grid access has been mentioned, the knowledge about existing solutions, and as shown, the lifetime of existing equipment. That's just a summary and contact slide. If you have any questions, please feel free to ask directly in the chat or afterwards. And these are some sources used. Thank you for your
Thank you. Thank you, Matthias. I mean, this is excellent, in the way to kind of contextualize, what we are talking here and to bring it, to the policy level, to real kind of market opportunities. And clearly, we are sort of positioning ourselves in electrification against natural gas. But what we are seeing, we see there is an urgency and there is this kind of acceleration of technologies. And even now with the liquid natural gas, I mean, there's sort of some implications on some of the sectors, when they change the furnaces. So we might have opportunities to electrify, even, the opportunities might be bigger and quicker coming, that we might have anticipated. So I just wanted to make a point that, if you have any questions for any of the speakers, put them up in the chat or Q&A. And we will bring them back, to the speakers at the end of the webinar. Now we're going to go into the sort of dealing with the sort of technical challenges mainly through presenting two EU-funded projects. One being eLITHE, which EIP is also a partner of. And they are looking, really, we're looking at the kind of technologies, in specific sectors. And secondly, we will have a presentation of CITADEL project, which is very interesting to what Matthias was saying, kind of covers, crossover, also within the materials. And this is something, which is kind of quite often overlooked when we deal with electrification of the high-grade heat. So Roberto, please, if you can share your screen and then tell us more about the eLITHE project. Thank you. I think, Roberto, you are muted.
Yes. Hello. Good morning, everyone. Well, I hope you can see the presentation in full screen. Okay. Well, I'm Roberto Arevalo. I work in CIRCE in Spain, and we are coordinating this project. I'm in particular the technical coordinator. I share the coordinator with my colleague Miguel. And well, this project is about the about electrification in the ceramic industry. We have 3 demo sites which carry out very different processes, all of them very challenging, as you can see, since we are aiming at temperatures well above 1000 degrees in one of them, and also in the calciner. We have a frit smelter. Let me go through them. We have a frit smelter in Spain, which is, we are reaching 1500 degrees, an alumina calciner in Greece, well above 1000 degrees also, and a bricks firing tunnel in Germany. So we are testing very different technologies. In the frit smelter, we are using electrodes and induction. In the alumina calciner, we are going to try a very novel microwave heating, and then the brick firing tunnel, we we are going to install a hybrid system using electricity and a hydrogen burner. And on top of this, we are also developing new materials that are suitable for electric treatment, new materials for to improve circularity, developing thermal storage systems, and also we are developing digital tools, as we'll explain later. These are the figures of our project. We are 18 partners, 3 pilots, 3.5 million of budget, and 4 years to make this. We are almost completing the second year. And well, regarding objectives, I already mentioned some of them, just to highlight here that we are aiming TRL 7, which is very challenging for these processes, as we are going to make demos in relevant industrial sites. And this is also very exciting, of course. And we are also naturally developing a roadmap for the replication of our solutions across Europe in similar industries. And to achieve this, we are already developing a successful communication, dissemination, and exploitation strategy. Regarding the baseline of our project, this is already concluded. Not going to stop very much here. We have established the characteristics of the processes, the materials needed, charted the energy flows, the possibilities of energy flexibility in each site, and so on. And let me go to more technical work packages. This is how our digital platform looks right now for one of our partners. Here you can see that they can check how the process is going. They can, in this platform, they can run simulations with the digital twins that we are developing. They can forecast the energy prices in the market. They can see what, if they're producing energy, the possibilities to exchange energy with the market or use it inside, if that is better. And we are developing this tool to be used by the 3 partners, specialized for each of them. And also within this task, we are developing the thermal storage materials. That is very exciting because they are being developed using wastes coming from each of the demo sites. So we have already received them, as you can see below. We have characterized them, and now in the KTH they are working towards the production of these materials that hopefully will be used within the demo sites themselves. That's completing the circularity of their processes. I go now to the core processes. This is the frit smelter that we are developing, the new one, with the electric solutions that are 2. In the upper image, you can see a simulation that we have used to actually design this system. Maybe you can see 2 bars that are the 2 electrodes, and below you can see the induction system. And we have already completed the engineering of this solution, this pilot. And here to the right, you can see that we are already constructing the pilot. Hopefully, we will have this fully developed in December to carry out the test and test that everything works as foreseen. And if this goes well, there will be another demonstrator with a size 10-fold capacity, 10-fold production capacity, that will be situated in our partner in Torrecilla. So this is looking very good, and we're very excited to start the test in next month. This is part of the also new materials because of course, changing from gas to electricity requires also new materials, both for raw materials and the materials that make up the furnace. This is part of the materials that we have developed and that are going to be tested in the new pilot. For the alumina calcination, here we are also well advanced. In the upper part of the slide, you can see our proof of concept, because microwave in alumina calcination is really, really very new technology. And this is, to my knowledge, the first or one of the very first demonstrations of the use of a microwave to calcine alumina. And well, that proof of concept was some months ago. And below you can see that we are already into the development of the actual applicator, as it is called. You can see the several parts. This is in the first pilot. In the left, you can see all the electric parts, and in the right, you can see the tumbler, no? Where it is going to be tested. Okay, and our last demo site is the firing bricks tunnel. Here we have a hybrid system, which consists of an electric system. But since this wasn't enough, we are also developing a hydrogen burner that is going to eliminate completely the use of natural gas. So it is very important to remark that in all of our demo sites, we are completely removing the use of natural gas. So if we succeed, as I hope, at the end of this, we will be completely decarbonizing concerning the core processes. Well, this furnace, as you can see, is also essentially already to be tested very soon. So let me just conclude the presentation, this brief presentation, saying that we have already fully characterized our processes and the materials that we need to develop. We are well advanced towards the first pilot test of our 3 technologies. And we are also developing the new materials for energy storage, and started a very fruitful dissemination campaign and established already fruitful collaborations with similar projects in electrification in the industry. And sorry, I forgot to include the consortium slide, but
Thank you.
I conclude here. I'm available for questions later or at any moment. Thank you so much.
Thank you very much, Roberto. And we will add the part the slide, with the people, also, and when we share the presentation. But this is very exciting, because I think it's great, what the CIRSE is doing and what you're leading really on this sort of innovation. And I mean, I didn't know that it's sort of first time, the microwave are tested, with aluminium, and it's very inspiring, and it actually really fits, what we had the previous 2 presentations on the kind of policy initiative, and then also on the market potentials. And it's clear that the research that you guys are doing, it's very kind of instrumental in filling, both of these sort of like a policy expectations and the kind of market potentials. To carry on, we would like to hear more on the CITADEL project. Sven, you can share your slide, and thank you.
So, yeah, hello also from my side. I hope you can see my screen. I have shared. You can see? Okay, then let's start. Yeah, my name is Sven Eggert. I'm a scientist at the Helmholtz Center Dresden-Rossendorf in Germany. And in our Institute of Fluid Dynamics, we are working on many projects to support the green transformation of the process industry. And the electrification is one of these research projects. And here we are the coordinator of the CITADEL project. So, which is a very ambitious one, and it combines research institutes of Europe and industrial partners from 5 different demo cases. The logos of all the partners you can see here on the first slide. So, yeah. I think the motivation is clear. There is no way that to work further with the combustion of natural gas for supplying the process heat to the industry, and we need we need a drastic reduction of the CO2 emissions. So, and the way we focus on in the project is to apply different electric heater technologies in order to substitute the fossil fuel combustion. But the goal of our project is not only to just to change the heating system, we also focus on improving the key performance parameters. So we have a look on the efficiency in terms of energy use and resource use. We consider the safety, the flexibility, and the robustness of the processes, and last but not least, for many applications, the product quality is also a very essential parameter. So we also want to use the advantages of electric heating because it's a very efficient form for heating the processes, and you can integrate it in a very flexible process control. So, and last but not least, we have to demonstrate that all the technical solutions we develop in the projects can be upscaled, they are cost efficient, and show economic viability. So the CITADEL project is funded since last year. We are 14 partners from 7 European countries, and we focus especially on the high temperature processes. We have heard already from Matthias that there it's in this area a lot of energy is consumed, and here also this is the source of dramatic CO2 emissions all over Europe. So, and in our process, we consider 5 different demo cases in the temperature range between 500 and 1600 degrees Celsius. We have the production of copper wires. We have an interesting project for concrete recycling, steel making, is with our Spanish partner CITADEL. We consider glass production and the production of refractory fire bricks. So, for each of these demo cases, we want to develop and implement demonstrators on the pilot plant scale. That means we are starting from a TRL level 5, and we would like to end up at a TRL level 7. So, and also we do not look only for the technical solutions for the specific processes. So also we have to take into consideration that at the end, we also need an effective use of renewable energies. So, and therefore we have also to consider the interoperability with the electric grid, and maybe we have to see if there is a need for using some capacities for energy storage. So because in this short presentation, I cannot show you all the details from all 5 demo cases, so I will concentrate on the demo case number 2. So here you see what we want to do in the terms of glass production. The industrial partner is the Slovenian industrial partner Rastnik. They work with 2 glass furnaces. The the operation temperature is more than 1300 degrees Celsius, and such a furnace has a throughput of about 160 tons glass per day. So, and our aim in the project is to install a hybrid furnace with a share of 60% of electric heating. So this should give us a saving of about 50% of natural gas and 35% of the CO2 emissions. So you can here see a process scheme of the glass furnace. You see here some photographs of the details. This is the burning chamber, where here you have the gas burners installed here in the current status of the process. So this is the tank for the glass melt. And here you see already at the bottom, there are some locations already prepared where we install electrodes from the bottom in order to heat the glass melt from the bottom by applying electric current. So for this furnace, we have already developed a furnace model, which gives us the possibility to do simulations regarding fluid flow in the turbulent melt in the combustion chamber, in the glass pool, and in the atmosphere above the glass pool. So we have to consider different mechanisms for heat transfer. The first of all, the radiation heat, but also Joule heating by the electric by applying the electric current. So we have to calculate electrodynamics in order to see the closure of the electric currents. We have to, from this, we have to calculate the sources of the heat. So, and also in this process, it is very important to have a look on the transport property of the species in the melt. So what are the main problems here? If we add electric heating to the process, so then we also add the location of the heat sources. So that means if also we heat from the bottom, then we will create some changes in the heat distribution, and this will also affect the flow in the glass bath and in the atmosphere in the combustion chamber. So, and we have shown that this could have an impact on the product quality. So we have to take care that there will be no increase of inclusions. And also it's very important to have a look on the coloring of the product. So, and this gives also as a limit for upper limit for the electric input, because if the electric current becomes too strong, then we can observe a bubble formation at the electrodes, and also corrosion issues become more important. So this is what we have to take into account, and these are the problems and the challenges we're working on in the project. So I would like to stress a little bit more the challenges we have to consider here. The good news at the beginning is that electric heating is an important technology which is already in use successfully in many industrial fields. So especially in metal making. So we know induction furnaces for melting of steel and aluminum. We have applications for forging and forming of materials, annealing, hardening. So you can see a lot of different applications already now. So, but what is the problem in many other processes? So here I look for the production of cement, glass, ceramics, paper. So, and this is the difference to metals is that here the materials have a very a poor electrical conductivity. So if you apply an inductive heating to limestone in the cement production, that at the beginning there is no interaction. So, and there is no heating at all. So you have to find some technical solutions. In this case, we are working on the development and the implementation of different kinds of susceptors for indirect heating, and to transfer the energy, the heat, then to the material to be heated. So herefore, we have to look for the key parameters, which is the heat transfer and the temperature distribution inside the materials. So, and the ideas, innovative solutions are also already available and verified on smaller scales, on the lab scales, for instance. So, and then also the upscaling is quite challenging. So for a typical cement plant, you need an electric heating input of 100 megawatt, and this is quite a lot. This is the same order of magnitude as the electric arc furnaces here in steel production. So, and in steel, you have a good heat conductivity. This is not the case for limestone. So, and therefore you see that we still have to do a lot of research and of innovation in order to develop reasonable technologies at the end. So maybe let's come to the summary of my talk. We are convinced that electrification of the industrial processes is a very important step for reducing the CO2 emissions. So for the production of process heat. So, and we have to take into our, or we know that we have major advantages given by electrical technologies, because they are very efficient and very flexible to apply. So, and we already have a broad portfolio of promising heating methods available, and then we have to bring it then to the different technologies. So also there are some alternative ways we can take into account the hydrogen, the CCS or CCU. So for instance, I come back again to the cement production. Here in the cement production, the major amount of the CO2 emissions is not coming from the heating of the process, it's coming directly from the calcination reaction. So, and maybe here we have to combine electric heating with CCS or CCU in order to make the to produce fully green cement. So, and if we change anything in these very complex technologies, we have to take into account that there could be an impact on the process in terms of efficiency, stability, and product quality, what we have to consider for each application. So, and what is also, in my opinion, a very important point is that we also have to consider maybe a general improvement of the technologies. So, because if we only do an investment in order to replace the combustion by electric heating, and you end up with the same level of product and productivity, so there is no economic benefit. But I'm very optimistic if we have the possibility to consider the processes in general, then also we can make some suggestions for a general improvement of the efficiency of the technologies. So, and last but not least, for a successful application is of course required that we have that green electricity is available at all times in sufficient quantities and acceptable prices. So, and also this is considered in our project, how to realize this and for the specific demo cases. So this brings me to the end of my talk. Thank you very much for listening. And of course, I would be happy to answer any questions you have.
Thank you, Sven. Thank you very much. And it's really, you know, your project CITADEL is very complementary to what we heard from Roberto, and it's both on the kind of side of technologies, but with also dealing with materials. And it sort of shows, you know, sort of really, I mean, for somebody non-technical as myself, you know, kind of level of complexity, you know, that we have to bridge between the innovation we have on one side, and then kind of we have the urgency, you know, coming up, you know, from Europe and the markets, and the actual kind of opportunities and potentials in Europe. At the moment, I don't see anybody, any of the participants, if they want to put any questions through. If not, you know, I would like just to kind of, if Adrian, if you're still here, and Matthew, Matthias, if you can kind of reflect, you know, very briefly to what you heard from these sort of, you know, more sort of technical project presentations. I mean, of course, you know, we are doing this, you know, it's supported by the European Union, and we're all kind of driving in one direction. But do you think this is sort of, there is a way, you know, for us, you know, to kind of accelerate the innovation also in Europe, and how can we bridge, you know, this sort of business model gap? Matthias, I see you have your hand up, you know, so please start.
Yeah, thank you, Julian, and also thank you, Sven and Roberto. I'm extremely thrilled to see that what I have to say, merely estimated in our report based on some insights and some discussions on these technologies we looked at, that this is actually being done right now, right? That the projects are out there that try to tackle exactly these challenges we identified as stopping the electrification of process heat from happening in some areas. I think that's extremely important to close this gap, and these examples, as far as I could see and I've looked at, really have a big contribution to that. But we should not forget that even if it's from a technology perspective ready, if we have these technologies, we still have to create the conditions that they are attractive in the market. And I think there's still a large gap, because we see that even the existing technologies do not enter the market as they could and as they should from a climate perspective, and possibly, as Sven pointed out, also from an efficiency and competitiveness perspective.
Thank you. Adrian, do you have any thoughts?
Yeah, I mean, big picture is it's really exciting. It's genuinely exciting to see that we have a number of challenges ahead of us and that they are surmountable, right? This is the main takeaway for me. It's a matter of putting in effort and time and money. Nothing good ever happened without doing those three things. So in that sense, I'm very, very excited. It also really confirms to me that this second act of the energy transition is not about people in Brussels putting in wholesale new policies. It's about deploying, and it's about investing EU funds, member state funds to help companies adapt to build those business cases. And there's a path there. There's fundamentally a path where this can happen. And the further we go down that path, the easier it becomes to do the things that are on the way, if you know what I mean. So if we deal with the low temperature process heat with their wonderful flexibility now, we increase that electricity market, we increase the supply of renewable electricity, and that means that further down the line, the more difficult business cases become easier. And that so yeah, it's fantastic. It's fantastic. These things are not done yet, but there is a path, a really clear path to success for Europe, and that's my main takeaway.
Oh, thank you, Adrian. Any questions? If no, I will see that basically for Sven and for Roberto. I mean, Roberto, I've seen in our digital tool in eLITHE, you already kind of include some of the kind of market elements, and already kind of potentials to go out of the system with electrification with systems. So there is already some sort of outside market orientation from the research projects. But how can this gap keep built, and how can we really kind of bridge, a little bit more and speed this up? And the key word these days in Brussels is competitiveness. And what I see, this innovation and the changing, ensuring the European industries are becoming, kind of secure through electrification is one of the main things. So Sven, if you can reflect briefly, and then Roberto, please.
Yeah, there is maybe there are many possibilities to support these things. So of course maybe my feeling, if I have contact to industrial guys, I see that they are really interested to learn new technologies and to apply new technologies. The situation was different 10 or 15 years ago. Then I came also with very nice ideas to the partners, and then you can do this and you can do that. Yeah, but maybe if you can sell me a product, then it would be fine, which we can apply in half a year. But do not touch the process. It's running well. So and now we have an open window in I think that they are now open for us, that we consider again, so we can reconsider the processes in terms of efficiency, energy consumption, CO2 emissions. So and then maybe then what we see here also in our project, that it's very important to bring both worlds together. The scientific world, which already had some ideas about the new technologies, green technologies. So and then the industrial people, because they have to learn which possibilities are available. So and therefore maybe such funding schemes what we have here from my point of view are very promising and perspective.
Thank you, Roberto. Is this something you share, working with industrial partners? Do you see this kind of interest and them keen to sort of implement the solutions? Your microphone is off. Okay, thank you.
Yeah. Well, yes, in the particular case of eLITHE, we wanted to enable the flexibility in two ways to use, because, for example, our demos are using several energy sources. For example, the last one in Germany is using gas and electricity, hydrogen and electricity. So we want to enable the flexibility to maybe leverage which one is better. Some of the partners already have production of photovoltaic electricity in their facilities already. So we want to give them this possibility to choose one energy or the other, depending on which one is more economically advantageous, and also to give the possibility to interact with the market by selling if they have any surplus of energy, although I suppose this depends on the country. And I think in Spain it's not very easy. But I think it's, well, always enabling these flexibilities is always going to be very useful and very advantageous for the operation and the economical operation of the facilities in general. That's why we wanted to do it.
Thank you so much. I mean, okay, sorry, you had.
No.
Okay. Basically, I mean, we're up to time, and I'm very impressed that we did actually manage to kind of encapsulate from the policy, down to kind of like down to very technical level. What I can say, that this webinar is just the first in the webinar, and we are very keen on developing and furthering these conversations. And the building up, kind of more on the financial element and going through the other elements, both, on this sort of in continuing cooperation with the Electrification Alliance and then also with on the eLITHE project. I have to say thank you to technical team, Irene here at the office at EIP, Sylvia, she did amazing work, in gathering people together, and thank you to all the speakers. And we are looking forward to continue and cooperate and watch this space. Thank you very much.
Thank you, everyone.
Thank you. Bye.
Okay. Thank you. Bye-bye.
Thanks. Bye-bye.
Thanks very much.
Thank you. Bye-bye.